Moving on to particle motion, this part of the Calc Bible does not really have a lot of example problems, but a couple things to be aware of. Of course, when you do your derivatives, you go from position to velocity to acceleration. Typically, motion along the x-axis. Particle is at rest when v equals 0. Hopefully you scribbled out that part. Changes direction when v of t changes sign. Moving to the right when velocity is positive, to the left when velocity is negative. Average velocity can be done this way, or when you actually do the fundamental theorem, that way. Speed is the absolute value of velocity. And if you want total distance traveled, you do integral of the speed function, as opposed to integral of regular velocity function gives you displacement. And this was a big concept. If you want your speed to be increasing, you could have a positive acceleration when you have a positive velocity, but also a negative acceleration when you have a negative velocity would be increasing speed. When they are opposite signs, your speed is decreasing. In that case, just show what the actual inequality is. V of t greater than 0, A of t less than 0, etc. Mean value theorem and intermediate value theorem are your two quotable theorems. Conditions for both are that you have a continuous function on a closed interval. The extra part for mean value theorem is that you also have to be differentiable on that open interval. And what it essentially says is slope of the secant line, the line drawn between those two endpoints, must be equal to slope of the tangent line at some place. In this case, C. And it's going to be at least one. Could be multiple places. Again, no examples here, just concept problems. One important thing, if you are given a graph of f prime, of course, look at what it is. Most likely it is going to be f prime or f double prime, not actually f. And so my recommendation to avoid looking at it is to just take that graph and translate it. When it's below the x-axis, you know you have a negative derivative value. When it's above, you know you have a positive derivative value. So that means those key points there, these places, right here, 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 and here are critical points. They're places where your derivative was 0. But only the places where you had a sign change would be a relative max or min. So we have a relative min at -4, and that would be because f prime goes from negative to positive. In other words, now that we have this, we figure out what f looks like. So a relative min at -4. Also a relative min at 3. And then we have a relative max at 0. 5 is neither, because our function continues to increase after that. Now for f double prime, you would look at where f prime changes from increasing to decreasing, which would be at -2 and at +2 and at 4 and at 5. In other words, all the relative mins and maxes on that graph of f prime refer to points of inflection on the original graph and places where we have concavity changes. So f prime is